So that one is fine. I don't know what.
I don't have any particular agenda.
Okay. Well,
Well,
I thought, so we're going to talk about your paper. I have it printed out because, well, just because I love it, but so I can actually read the title in the right way. The Hippocampal Formation and Action at a Distance. I mean, that's a pretty exciting title.
I should send you the talk that I gave, with that title,
Please do.
which was I should have thought to do this before. Once you said you wanted to concentrate on that. Yeah, it's a kind of a general approach to the issue of how important it is to link things across time and space in a way that allows for causality, you might say, between things that are not directly in the same space or in the same time. So it's action at a distance. How do you get action at a distance? I mean, the physicists talk about that as something that can't happen, so to speak, or shouldn't happen. Although the quantum entanglement the talk goes into a little bit of that. It starts out with quantum entanglement. Yeah, okay.
Yeah, you talk about spooky distance, Einstein in the paper too.
Yeah, that's it. So I sort of play that out a bit in the talk, and then I move over to we humans, animals, are constantly doing things, that involve action at a distance. We behave based on things that happened hours ago or weeks ago or months ago. And we engage in spatial behavior based on things we don't see. We navigate to goals that we don't actually see at the moment. So somehow we have to bridge those things. We have to bridge them in order to be able to behave appropriately in space and time. But then it gets more interesting because then the question of how does learning occur? I mean, how do you connect up things in learning when there's a gap between the cause and the consequence or something like that? So, you need a system that actually bridges those temporal gaps somehow. And the claim is that the hippocampus is sort of integral to that capacity. And in fact, there's, I think it's laid out in the paper, there's pretty good evidence that without a hippocampus, animals are not very good at bridging those temporal gaps, that the kinds of tasks that require them to do it and the sort of knowledge that you build up about the world that, is somehow a distillation of things that are separated in time and space. That without a hippocampus, you're pretty bad at those kind of things, if not hopeless. So, that's the backstory, to the general idea that, that amongst other things, and partly as a function of what it actually does by helping form memories, which is one way to bridge time, and forming cognitive maps, which is a way of bridging space, that the hippocampus permits the system, permits the organism to act at a spatial and temporal distance, so to speak, from things that it either wants to get to or wants to, make use of from the past. That's the rough claim, and it's a kind of an overarching story about what the hippocampus does and the actual things it does, forming maps, building representations, over multiple experiences in the same environment. Somehow you have to connect those things up. I mean, when you go back into an environment you've been in before that you only partially explored, you want to add the new information you're gaining from the second time you've gone back to that environment to the one that you made last week or a month ago or whatever. Well, how do you do that? I mean, it's easy to say the words, but how does the brain actually do that? In order to do that, it's got to access the appropriate old memory. It's got to reactivate it in some way. It's got to have a mechanism for adding new information to this old memory. I mean, all of that is, those are actual steps that the system has to take in order to accomplish this ability to aggregate information over multiple experiences, that it judges to be relevant to each other, even though they're separated by time. So again, the claim is that the hippocampus allows you to do that. That actually is part of the critical machinery that allows you to stitch together those sort of temporally separate occasions that are linked by the fact that they occur in the same context or something like that. Yeah. Anyway,
Yeah.
that's the idea.
It's interesting to think of action at a distance, because I even think that in physics, it's discussed through motion. Like motion is affected without the two being in contact. So that's interesting with the hippocampus. But I think before, you can correct me if I'm wrong. I have the paper, I can look it up. But someone had talked about this. Was it not Davenport, but had talked about action at a distance in relation to the hippocampus, and you're bringing in the spatial aspect here too, and time.
Yeah, but
Um,
again, but memory is the linking device. I can't remember which paper that was. A number of people sort of raised this idea, but they never really took it all that seriously as a framework that might organize a lot of what we think about when we think about the hippocampus.
To me, this goes to, hippocampus as a cognitive map, which you and I talked about a
Yeah.
lot. And you're building out of those ideas a lot. There's a lot about the cognitive map itself being
Hmm.
this kind of structure that you're thinking of as doing what you just explained. And there's
Right.
some part in the paper where you kind of say, yeah, we came up with all this, 45 years ago?
Yeah, it's more
And
like 50 at this point.
50 now, yeah, because this
And the
paper is
ideas, yeah, the
2021.
ideas started in the kind of early 72, 71, 72. Yeah, it's over 50 years now.
Wow, that's like hard
Wow.
to get my head around.
Me
It's
too.
amazing how long it takes for people to start to understand the ideas, too.
Well, there was always some understanding of it, and then, once the grid cells came along, it really became much more
Well,
popular,
that's
so to
that's what
speak.
I mean. It's been this whole process, though, if you really
Yeah,
think about it. It seems like, oh yeah, that's how it
yeah,
went.
yeah, yeah,
But
yeah,
when
yeah,
you hear 50 years, it's like, oh yeah, these things take time, and that's just a blip too. 50 years. I mean, but
yeah,
anyway, this is kind of part of what we're talking about, right? From
yeah.
where we are now, this looks different. But the point is, in the paper, you say, yeah, we came up with these kind of ideas about the cognitive map and the hippocampus as a cognitive map, and over time, those have kind of played out. You and I have talked about that, and others on Come on the Research podcast have talked about that as well. Over time in hippocampal research, a lot of these things have actually kind of structured even a whole area of hippocampus research in a way.
Much of it,
Yeah,
I
a
would
lot of
say,
it.
yeah, yeah, a
Yeah,
lot of it, certainly.
because but here's the kind of thing that's been happening that I feel like this paper is addressing, and I'd like to see where you're at now because you wrote this like 5 years ago. But you say at some point, okay, all of that is happening with cognitive map theory and so on, and we're making progress, but we still don't really know how to understand like the same system, the hippocampus, the hippocampal formation, whatever we want to call it. This area of the brain is doing all of this stuff with space and time and also with memory. How do we understand all of that together? Because what's this neural system that's so intimately involved with the space and time and navigation, and so intimately involved with what we think of as memory? Do you see that as still such a question?
No, because actually the two are totally intertwined and dependent on one another, basically. I mean, for a long time, people were saying, why is this spatial navigation system happening in the same zone as memory, so to speak? But no, I mean, I think this proposal is a proposal that, it does space and time as a memory function, and that allows one to bridge gaps in space and time. I mean, let's assume that there was no memory, right? And the system was still involved in space and time and would allow you to navigate, just in your immediate environment, basically, and to string together temporal sequences of movements in an immediate environment, but you'd never remember it and you'd never, you wouldn't have any memory from prior experiences. Basically, it's just a system, an online system for navigating in the immediate environment. Yeah, absent, okay. I mean, it might be useful. You might be able to claim there are animals where, you know, more primitive animals where that's what the hippocampus does. It just helps the animal navigate immediately in space and time based on the things that it sees right in front of it. Maybe early, way hundreds of millions of years ago. That's what was the case. But in order to make full use of that system, and to be able to build on what experiences you have, then it necessarily becomes a memory system. You need to be able to remember, where things are in space. You need to be able to remember the sequence of things that you experienced in space. So I don't see any separation between them as if they're two different functions. Like here's color vision and here's, you know, black and white vision, and somehow they act together, but they could be separate or something like that. Or here's vision, here's sound, and they're two completely separate things, but you can put them together sometime. The sort of the space and time notions in hippocampus kind of depend upon the idea that they are memory systems for space and time. They're not just space-time systems, they're memory systems for space and time. And those things just naturally have to go together. And when you put them together, then you come up with this idea, that when they run together, then the system will allow the organism to act on the basis of things that are distant in space and time,
So you bring
just like that.
I mean, I agree, but I think, even just 4 or 5 years ago, that would have sounded a bit strange because people were sort of studying memory and people were sort of studying the
Yes,
so-called GPS of the brain. We thought, oh, those, how do we put those together? It seemed like a big
absolutely.
puzzle.
And
And
I was saying some of the same things for quite a while, that, this is a bit of a puzzle. The field is spending time trying to figure out why a system that's a memory system is also a cognitive map space-time system. But now I think it's necessary. I think for it to be of any use, it really has to be a memory system. Can't just be an online, you know, robot that just basically deals with the immediate environment. It's got to actually create a model of the environment
yeah.
in space and time. And once you do that, then, then that kind of bifurcation and, the problem dissolves. It's no longer a question of how can the same system be doing these two different things. They're not two different things. They're actually inextricably intertwined.
But we measure them in different ways, right? So when we're trying to look at something that we call memory, it
Not,
depends on the memory, but I
not,
mean,
yeah, that's the point. No, I mean, yes, of course, there are kinds of memories that have nothing to do with space and time. So it's not that this is a system that encapsulates all memory. My memory, for how an apple tastes has nothing to do with space and time. So I've got memories for the quality of things in the world, that are totally independent of space and time. That, they're
but if
not
you looked at that from another angle, I think that's what I'm trying to say. Couldn't you could say, "Oh, I have this memory of the apple because my grandmother always gave me apples and I miss my grandmother." So that's
that
kind
may
of
be
what I'm
why.
saying.
Sure.
It depends what we're looking for, that what we're gonna how we're
Sure.
gonna use these
That
things.
may be why, but I think the problem here is that the word memory is ill-defined in that equation. Here's this cognitive map of space, let's say, and then here's this memory function. And if you think of this memory function as including all kinds of memory, like, memory for the taste of an apple and so on. Now, you may have acquired that memory from a particular episode in space and time, but you probably don't even remember that. That's not a critical part of your memory for how an apple tastes. The problem is people wouldn't use the word memory to describe that. You wouldn't say, "Oh, I have a memory for how an apple tastes." They would say, "Oh, I have knowledge about how apple tastes," right? But what is knowledge but simply the accumulation of, the information we acquired into memory? So the word memory is kind of poorly articulated in these debates. I mean, the idea here is that a certain kind of memory, namely about the distribution of things in space and time, is involved with the hippocampus. Other kinds of memory, which may be parasitic on this kind, but which nevertheless exist on their own, those other kinds of memory don't require the hippocampus and don't have anything to do with space and time kind of literally, although they obviously were acquired at some point in space and time. But that's not an important part of that memory. It's now just some general knowledge you have about the properties of things in the world. The particular property that the hippocampus is concerned with in terms of memory is the distribution of things in space and time, in the past. These are the experiences I've had about the distribution of things in space and time in the past. And you build up a cognitive map based on that. So they were just completely hand in glove. It's really a hand in glove kind of thing. You can't have a cognitive map without it being a memory system, because you can't acquire a cognitive map all at once, right? It necessarily involves putting things together over time. And sometimes the time is continuous, so you could make the argument in some sense that it's a single thing, but quite frequently it's discontinuous. As I said, the example I gave before. You go into an environment, you sample some of the stuff there, you go away. 2 weeks later, you come back to the same museum and you kind of investigate a different part of that museum and you add that to your knowledge. And so, I mean, so uh, very most of the time we're building up these knowledge bases uh, about the distribution of things in space and time, over in in disconnected episodes, so to speak. So it's really a problem for the brain to put all that together. So that becomes part of what the hippocampus is doing, allowing the brain to put things together that belong together because they happened in similar spaces, but at quite different times.
So if we go to the museum and we could imagine that we're there for the first time and we
Yeah.
explore it and we're sort of creating interactions with that space that when we
Yeah.
come back to that space again, we're going to interact more easily. I'll know how to go to certain.
Sure. And you do that by activating your memory for that, for your prior experience there, right? That doesn't,
Or that's the same thing, isn't it? Like I'm not activating a memory necessarily and finding my way. I'm sort of at the same time, both of those are happening, aren't they? It's not, or do you think I stand and I say, okay, now I will activate my
no, I
memory?
don't think, yeah, no, you're on the right track. I mean, this doesn't happen consciously, but it is the case, when you walk inside, say the Rijksmuseum, which, I've been to for three or four times, and don't have a very good mental map of. But, I know exactly where it is in Amsterdam. I know what the entrance to it looks like. I mean, I could easily identify it from pictures. I know if I'm walking in that general part of Amsterdam, I know exactly where it is, and I know where the Van Gogh Museum is relative to it. Hopefully, it will survive. I know it's having some financial problems.
Mhm.
So, so when I walk into the museum, I mean, I don't consciously activate, but the cues that I get that are familiar to me will activate, whatever information, whatever knowledge I have about the layout of that museum is going to get activated just by some partial cues.
Yeah.
Then the
And
hippocampus.
that's the same process. That's not like
That's
two
all the
different
same process.
processes that we call
Yeah,
memory and we call navigation.
yeah,
But they're
exactly.
studied like that. So it can be very confusing, I think.
Unfortunately, they got separated, in the way people were studying them.
Or
But
maybe just so that we could understand them more. Because I
and
think
that's
the confusing thing is, and maybe you have some insight here, is once we go home, and it's funny you were talking about the Rijksmuseum because that's what I was imagining. So that's
yeah.
very weird, like action at a distance there. I was literally imagining going in there because I was there not too long ago. But anyway, so like I go home, right? Now I'm home. I'm not anywhere
Yeah,
near that museum, and I can just sit here and remember.
absolutely.
And I think this is why this is becoming, at least in neuroscience, not so hard to understand that you can have something like a kind of space that you're navigating
Hmm.
as you're remembering. But I think that's still a very hard idea. So I wonder how you think of that, right? So we were at the museum and we've created these kind of cognitive maps, as you would call them. But then when I come home and remember that, what's going on there, would you say? Is it kind of just the same sort of process as when I was there?
Well,
Or
it's certainly using the same system. I mean, it's not exactly the same as when you were there because you don't have the supporting, sort of external stimulus. But yeah, it's part of the same, it's part and parcel of exactly the same system. I mean, then you replay. Essentially, you're replaying in your head or reactivating in your head, that knowledge structure, that cognitive map that you built up, when you were visiting. And that then allows you to imagine walking through the museum to, if you know the museum really well, how you get to the particular paintings you really want to see, all the kind of stuff you do when you go into a museum. Um, I think if you go back to the 78 book, we made it absolutely clear from the very beginning that what we were talking about was a memory system. We did not separate them. This is the spatial navigation system. And then there's this function of memory, which somehow, connects to it at some point. No, we were very clear right there in the first page of the book. We are talking about a memory system, right? A particular kind of memory system, that deals with space and time. So it's true that that didn't settle the debate. That didn't convince people that these things should be thought of in the same breath, so to speak. But, our commitment to that idea that those things were inextricably intertwined was there from the very beginning. I mean, when I wrote later that people are struggling with how to fit them together, that was other people that I was writing about. Other people are, spending a lot of time trying to understand how these things go together. For us, it was necessarily the case that they went together, that, that a cognitive map is a memory device.
and You also talk about Kant a lot in that book and also in this
Yeah.
paper. So, and we talked a little bit about how memory is a kind of an impossible word to
Hmm.
define, and we don't really need to define it. If anything, what this would be another conversation, but a lot of people have been trying to understand that we've come up with the word memory to discuss something that, isn't necessarily one thing. To look for a memory is kind of a bit of a strange
Hmm.
stance to take, right? So we're
Yep.
not, that let's leave that for just a minute because space and time, to go to Kant and to go to your 50 years of work, those are also kind of tricky words. I mean,
Hmm.
we can go back to Leibniz and Newton, which Kant talks about,
Yep.
where you have absolute space, or you have something like where space isn't about the material relations. And there's been constant arguments, not too separate from the ones we've had about memory and navigation.
I
And
mean, I haven't, occasionally I dabble in the philosophical literature again to see what people are
you
saying
seem to
about.
like Kant. Is he your favorite? Because he comes up.
Oh, totally. I mean, I think Kant got most things right. I mean, I think by and large, he's the philosopher, who got most things right. But, and I go back occasionally to read. People are still arguing about, absolute space versus relative space. And, it's kind of an interesting philosophical debate. But I can't say I have any new insights or thoughts about it, particularly. And I think the claim we made is that we create a psychological space that fits what Kant said. Not that the physical space is actually like that. I mean, in the real world, who knows what's the case? We're just talking about what the human brain, but obviously what the vertebrate brain or the mammalian brain, and not just the mammalian brain, because insects have the same thing. What brains in mobile animals do. Now, would you say do plants have a cognitive map? I would have to say the answer is probably no, right? Although I think plants demonstrate many of the same cognitive phenomena like memory, and so on that we do, but they don't have a cognitive map because they don't really need one, not for space, because they're not moving, right? Anything that moves in the world, in some intentional way, needs to have something like a cognitive mapping system in order to benefit from its prior experience. So that's a big statement, but that's just it can't be any other way as far as I'm concerned. It has to be like that. And so the philosophers are talking about, partly about, and Newton and Leibniz were talking partly about what the real world was like. But what John and I were talking about is what is the psychological world that we create inside our heads, which of course has to be consistent with what the real world is like, but it doesn't have to be exactly like it, down to the microscopic level. And we know it's not, basically. You get down to the microscopic level, and the table that we think is a nice flat surface is actually rather bumpy down at the atom, the atomic level. But we don't sense any of that, and that doesn't matter. And the world may actually not conform, at various scales to Euclidean geometry, like Kant would have argued and like we argued, but that's not our problem. Our problem is to have a system that actually allows us to effectively move around and adaptively in the world that we live in. And sort of the Kantian and the sort of Euclidean space of Euclidean absolute space does that job perfectly well. And, from an evolutionary point of view, it's a much easier solution than kind of building the brain on, kind of non-Euclidean Riemannian geometry or some weird thing like that. Um,
Yeah, well, a lot of those things are ways we've tried to put some kind of model or structure into the world so that we can all talk about these things. I mean, so thinking of trying to find that specific kind of thing, like Euclidean
mhm,
geometry or something in anything, is a bit, I mean, of course, there's arguments about all of this, and even
mhm,
about what Kant meant by space and time, right? Because he talks about it as a form of intuition and it's not
mhm,
objective reality, but then he actually opens kind of by presenting Leibniz and Newton's views. And I imagine it this way. You can tell me how you feel, but and I even imagine, as you know, your work a bit like this, but that instead of having to choose these options, we're
mhm.
either objectively, everything's absolutely outside or everything's absolutely inside, that there's some interactional thing going on that we're all trying to figure out. And
Totally.
you got to
Actually,
hold that, and you can't put it into words precisely.
yeah. Actually, we're just finishing up a paper. Me and Mary and two other colleagues are just finishing up a paper exactly on this question. Sort of the debate between inside out and outside in, the Busaki kind of argument. And this is a paper about the generation of meaning, and where meaning comes from, so to speak, and how the brain basically represents meanings. So paper is going to be sent off for publication in a special issue of Philosophical Transactions, we think, within the next few days. So we're very much thinking about exactly how do those things come together? Because even though the brain doesn't have to construct something that is sort of microscopically faithful to the outside world, it has nonetheless, in fact, evolved in that world, so it has to capture, the aspects of that world that are important to a species of a certain size, that has the capacity to move around. So it's going to be an approximation to that world, but an approximation that works, basically, that has worked evolutionarily. That means animals who have it survived and reproduced, and animals that don't have it didn't survive and didn't reproduce. So, so how does that external world kind of basically anchor, this internal system? So the evidence is that this internal system is hardwired. I mean, the latest evidence from the Moser lab, which of course I'm here and hearing about, in terms of the grid cell coordinates system that the grid cells provide to the whole network, that's there before rats even open up their eyes and start to move around in the world. That shows up on day 10, post independent of anything the rat has done. It hasn't even, again, hasn't opened its eyes. It's not moving around. That system, the core features of that system, the nature of the way it works, is there by day 10, independent of anything else. So that's something that presumably evolution has built. It is built in this coordinate structure that provides the scaffold, that organisms can use to attach actual experienced information to. So I have this kind of scaffold, and then I experience in the world that the table is over here, the thing is over there, and it just gloms onto this coordinate system, this hardwired system that provides the framework for thinking, effectively about space and time. And according to us, it's a Euclidean framework. Again, because it works, not because it exactly mirrors, hyperdimensional space, but because it on this planet, in the time, in the way, in the environments that we move in and function in, it works perfectly well. It does the job, basically. And it's computationally easier than one would imagine other more complex geometries would be. Basically, it's a kind of a geometry that the system can handle, so to speak.
Yeah, I think that's really fascinating. You see that with a lot of the body and a lot of the brain too, where you do have this sort of basic scaffolding. I mean, we're born and we are here. We have structure, and it seems very strange that we wouldn't have that structure
Yeah,
towards
exactly right.
interacting in particular ways.
Yeah. The
So yeah,
question is how to, ontogenetically, how does it emerge? Is it affected by experience? Can it be broken? Can it be changed if you have different experience and things like that? So again, the Mosers in some experiments some years ago, they raised rat pups in a non-Euclidean environment. I think I told you about. I think we've discussed this before.
I've discussed it with people before. I was actually just about to bring it up. Yeah, and it
Yeah.
did shift a bit.
It shifted a bit, but not in a significant way. Basically, the main framework, the main Euclidean framework remained intact. There were some minor, distortions, but it was nothing that you would, write home about. So their conclusion was no, but barring a completely dysfunctional early developmental environment, where the system itself doesn't develop the way it should, doesn't get enough nutrition or, or something like that. Barring circumstances like that, which do occasionally happen, of course, and we can do them artificially, the system will inevitably have those properties independent of specific experience. Now, it may be like as in the visual system, you need to have some input to just, you know, jack up the activity, but it could be random input. It's just got to be something to get the system going. But the system self-organizes kind of developmentally to have those properties.
Yeah. Well, we're all in the womb and we're, coming. But you brought up a couple things that are really interesting about if we don't have the hippocampus, and there's so much evidence, before we got to John and you and
Sure.
navigation and all of this, we understood, okay, the hippocampus is memory, and there's Clive Waring, or there's HM.
Sure.
And you were talking about you're kind of living in this perpetual, you talk about Quirkin's book in your paper, but that, if you don't have the hippocampus or if you have some trouble, you're almost in a perpetual present.
That's
Um,
exactly right. That's the assumption. Yeah. Or
and
you're in the present where the present is a kind of a small temporal window. I mean, whatever that window is, it's fairly maybe 20 seconds or something like that. But that's the
yeah,
window. That's the window where, you have a little bit of time to play with. But outside of that, you're basically out of business.
yeah. So with these people, you can't learn something new, like how to go to a new grocery store and still remember it the next day, for example.
Right. Right.
And you won't remember it either. So both of those kind of
Yeah,
layers
yeah.
that we were talking about
Right.
are,
Right.
are connected. But also, you brought up the plant, which is kind of interesting because, this is this whole controversial thing about, do other creatures have cognition? And,
Sure.
yes, they have it differently than humans, but it's interesting to think of the cognitive map, right? Because if we think of having hippocampus damage, where we can't create these cognitive maps in the way we're talking about here, and we're in the present moment all the time. And now, I'm not saying that's like a plant, because a plant is nothing like, it doesn't have a human brain. It's nothing like that. But
Hmm.
I just planted all these crazy sunflowers this summer, and they got so tall. And, we had to kind of move them around like with the string, because they were just everywhere. And
Hmm.
you do notice that they immediately turn. I mean, I might wake up and they've completely changed their direction and gone another way.
Hmm.
I don't know how they grow so fast, how they change their direction, but they're in a kind of, they are moving and they're in an interaction.
They're moving, yeah, yeah, they're interacting with the environment, in particular where the light is coming from, for
All
example.
life is sort of doing that, right? I
Yeah, yeah,
mean,
right. I
isn't that,
mean, these are tropisms, right? I mean,
yeah,
there's a word for that. I mean, so they are, they alter their behavior, in a tropistic way with regard to moisture, probably with regard to light, with regard to odor plumes. There may be a variety of things like that that will influence. Certainly, plants exchange pheromones. I mean, I don't know if they're called pheromones in plants, but they influence each other by emitting stuff that, has odor, or so, basically. Yeah, yeah, I think plants are pretty cognitive, in most ways, except they just don't, because they don't move, by and large, or at least they don't move,
they don't
they move their
change their
parts.
whole position. They
They,
they
they don't,
move, but
they
yeah.
don't move their position, right? But they do move, but not their position.
I guess
Yeah.
what I'm trying to get at is that, when we're trying to understand, like, why are we even studying all this? And in a way, it's because we want to understand how all this amazing stuff is going on,
Yeah.
how we know that we know. And I really feel like memory is such an important idea. And of course, how we find our way through the world in the most metaphorical ways and the most literal ways is
Hmm.
so important. And I think we can get lost from that in a way, but if we just kind of for a minute just take life as it's trying to make its way through the world, and it has all these different ways of doing that. There's
Hmm.
something about the human, right? And if we want to call it the cognitive map, or we want to think of it in other ways,
But it's not just the human. I mean, it's every
not
animal.
just the human, right? But we're talking about the
Pretty
human.
much
But
every invertebrate, since the, jawboned fish. I mean, it goes back at least 350 million years in this lineage that you see something that is essentially a cognitive map. That's what it, so all manner of animals. And,
yeah,
there's a lot of science on this. In fact, there's going to be a symposium. Are you going to be at SFN this year?
I don't know yet. I got a lot of stuff going on.
There's a lot of stuff going on.
Yeah.
I'm not going to go probably, but there's a Carger, a Johnston Club symposium this year, organized
Oh yeah.
partly by Menno Witter, who, by the way, is living outside Amsterdam now. He's moved
Oh
from
wow. Okay.
Trondheim. He was just up here last week, so we saw him a bit, but he's now living in a little town about 40 minutes outside Amsterdam.
Oh wow.
I can't remember the name of it, but if you
Probably near me then. It's not Zeist, is it?
no, no,
Okay.
it's not that. Anyway, that workshop is about comparative approaches to hippocampus, and it's
Mm,
got various people in it that are going to talk about, the kind of the way in which this system has been preserved across eons, essentially. Again, because it's crucial to animals that move around in the world. Yeah, and some of the best work on this is done by a group in Seville, Cosme Salas and others who are, who've been studying this in lizards and turtles and fish, all that kind of. It's the same system essentially. It's-
So there's something about locomotion. Can we
there
call
is
it that?
something about there's something
It
about
changes
the
what we need
capacity. Yeah,
cognitively. The
yeah,
cognitive kind of
yeah,
composition of the being. Is that,
yeah.
can we say that? I mean, is that
Any animals that move around the world intentionally need it. Now, of course, you have animals that move around in the world unintentionally. They just
like a
get,
slime mold or something?
like molds or, or things in the ocean that just get swept around by tides. They don't actually choose where they go. They just get so there are animals that are moved around in the world, but they don't do the moving themselves. So therefore, they don't have to make decisions about where to go, so to speak. And given that they don't have to make decisions about where to go, then they don't need a cognitive map. They just go with the flow, literally.
Yeah. Well, a slime mold is interesting though, because it does move towards a goal and it moves the way a sunflower moves towards the light.
Yeah, it's
So,
tropistic. Then
yeah,
you right. Then you go from animals that are just moved around randomly by the
right. So there's
exigencies
no
of the
linear,
world,
clean way to
right?
talk about this.
And then you move on to animals that move, according to tropisms, where you have a gradient of odor or light or temperature or something like that, and they can approach and avoid, those things based on this gradient, right? And then you move on to animals that, have much more flexibility to combine sources of information to behave in a much more flexible way in space, where they're not dependent upon an odor plume or something, or they may still use those things, but they're not dependent upon those for getting around in the world. So there's a progression, of ways in which mobile animals interact with the spatial world, all the way up to, the map idea, the internal model of the world. That's the key idea here, that animals, at some point, animals acquired the ability to form an internal model of the spatial distribution of things. That's memory, right? Right. So as soon as you put memory into this, you end up with maps.
And how do you see like an internal model as different from an activation pattern or a habit or something like that? I mean, do you?
Yeah, yeah, yeah. You could make the argument that an internal model is nothing more than a bunch of habits, that they get linked
That's a
up.
lot actually to have a bunch of habits that you
Oh,
can.
yeah, 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 yeah. I mean, the argument for why it needs to be a map rather than just
Why not a mapping? A happening,
sorry.
why not a mapping? Why a map? Like an is it? Do you really think of it as a noun, for example, or as a cognitive?
Yes,
It's
yes, I
mapping.
think
Right? You think of it as
yes.
something that you can actually find in the brain.
Well,
I
that's
mean, we
hard.
talked about representations before, so we don't have to
Yeah, this
go.
kind of gets to that issue. What does it mean to have a map? Um, I think about it as a thing. It may not be a thing that you can actually nail down and say, this is the thing I'm talking about, but it's a thing that exists, not just something that is built on the fly every time you're in a given situation. It's not just something that you can create, on the go. It's an actual pre-existing thing, that it's a model. It is literally a model of the world, that you can activate and use in some way. So yeah, it has a physical instantiation that if you were smart enough and had a kind of a powerful enough computer in your head, you would be able to say, well, the map is, the combined activity of these 2,473,000 neurons, which I've identified using these new neuropixel probes that allow me to record from thousands and thousands of cells simultaneously. That the model is, somehow there is a model in there. We just can't actually, it's not like a physical map. We know that, and we know that these things are distributed in ways that you wouldn't be able to point to them as a physical map, but it has all the properties of a physical map because it
Yeah,
has all the information involved, that is captured by the interactions and interrelations between the bits, that comprise the map. I mean,
yeah,
one of the interesting things, and it's in this paper, is when you don't have the hippocampus and you're trying to understand the causal relationship between things in the world. What caused what? Arguing backwards, if you have a hippocampus, you're able to make causal leaps that jump over time and space. You can say that this thing this thing that's happening now, is related to this thing that happened, a week ago. You can do that. And you can then say, now I can derive certain properties based on combining the knowledge from those two separate experiences. If you don't have a hippocampus, you're really confined to drawing conclusions based on a much more narrow definition of what sort of caused what. This just simply recapitulates the argument about the relative importance of temporal contiguity, which are the things that are happening right now together, versus contingency. And contingency requires a much broader swath of time that might force you to jump across time gaps. This is in the paper,
Yeah,
right?
there's a really interesting section on it.
And
Yeah.
this is where, and this exactly, and this is where those Davenport papers
Right,
come in, because what it means to be an organism that is completely dominated solely by temporal contiguity is to be an organism that is, in quotes, superstitious. Any two things that happen close together in time, a brain like that will assume they are causally related because that's all it's got to go on. It
Yeah,
doesn't have.
Davenport and Holloway reported that rats with hippocampal damage were slaves to temporal contiguity alone and were, in effect, highly superstitious. So it's
Exactly
exactly.
right. So and the interesting thing is I think people vary on this dimension.
Hmm.
I think there are some people who jump to conclusions based on, very little input and very little data. They just happen to see that this occurred next to that. And it might have been a coincidence, it might not have been, but for some people, that's all the evidence they need, right? Then there are people who, you know, necessarily take a much broader swath of data into their consideration. They're using their hippocampus more to link, first of all, to get a sense of the base rate, of occurrence
Yeah,
of these
yeah.
things. I mean, so it's not just that these two things ever happen close together in time. It's do they consistently happen together close in time? And how often do they happen separately from one another? So in which case, if event A happens 30% of the time and event B happens 30% of the time, are those the same 30% so that they are always together, or are they just randomly happening 30% of the time? And some of those times they're going to happen together.
Mm.
And if you're a superstitious animal and you happen to experience one of those times when A is followed by B, you will conclude that A causes B or that A leads to B. You will not take into account the fact that A happened a lot on its own and B happened a lot on its own, because that requires bringing in information that is not right here and now. That
Mm.
requires acting at a distance, right? So in order to bring that information into this is what Rescorla and Wagner kind of were all about, basically pointing out that it was contingency.
Reminder.
It
Yeah.
was contingency and not temporal contiguity that kind of determined learning. What Davenport stuff shows is that, yeah, that's true in an animal with a hippocampus, but in an animal without a hippocampus, they're not Rescorla-Wagner animals. They're Skinnerian animals, or they're whatever, Hullian animals. They just basically behave on, what just happened in temporal contiguity. That's the driver, basically.
Yeah, I love this part of the paper, and I think it's such an important thing right now to think about in a lot of ways, because you also bring up the future in this paper a lot. And, because we're remembering and imagining are not that different, actually. We're doing
Right.
something very
Absolutely.
similar.
Yeah, yeah, we assume so. Yeah.
And this is why I bring up, do you really think the map is a thing? And why I think that's an important question, and a very, why you and I have talked about these things, representations and so on. But let me just be messy here and you correct me or just say what comes, okay?
Mhm.
Because I think it matters a lot right now. And I want to try to understand it. I've been trying to understand it. So you talk about, uh, it can sound like there's a little map that we sort of use and that it's solid. And I know you're not saying that, but also it's not, everything that we're experiencing is changing kind of that immediate map, or mapping
Mhm.
is what I would prefer. But
Okay.
there's layers of this, because just as we're like, if you and I go for a hike and a snake comes out and I move out of the way, I didn't think about it, but I knew
Hmm.
to move out of the way.
Hmm.
And but also, we do that in our memory too, or in our thinking, or in our remembering. We can be lost in thought, for example, or
Hmm.
we can know that we are thinking about something. So there's not you talk about this in the paper, how it's not linear and you're trying to open up to different ways.
Hmm.
And I think it's very hard. But I think also when we're thinking about mapping, because
Hmm.
those are, if we generalize that to the way it's talked about in everyday life, we
Yeah.
think we have these memories which are true or false, and we pull
Hmm.
them out and we can compare them, and it actually isn't working like that, which is why,
No, 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 no. And I think more people are
it's
understanding.
mapping. It's almost it's almost like the hippocampus allows us to communicate with ourselves or something,
Well, yes, but also to constantly update our own knowledge,
which is a kind of communication. I
which
mean,
is a kind of communication
and
with
I don't
each.
mean there's a
Yeah,
thing sitting in our head communicating. It's a whole body
yeah, yeah, yeah.
uh,
I think that's a
experience.
reasonable way to think about it. Absolutely. And I think the field in general, the memory field in general, is moving towards this much more dynamic understanding of what, memory really is and does. It's not a fixed thing. It's constant. Your memories, you are your memories. Your memories are in constant dialogue with the real world,
With
basically.
everything you're putting in, whatever you're
Yeah,
watching on YouTube,
exactly right.
whatever you're
Exactly right.
reading, the people
Right.
that are around you, those are shifting the algorithm, so to speak.
All the time.
You
Yeah,
know,
absolutely. And so
yeah.
that's
This is
the
very important. I don't know if we, to talk about the superstitious thing that you brought up. I don't know if we
Mhm.
realize how that's happening.
No, I don't think
That
we
we're
understand
doing
it
that
at
to
all.
ourselves through what
Yeah,
we surround
yeah,
ourselves with,
yeah, yeah.
even though we do, of course, have unique, real, findable patterns that
Sure,
are,
sure. I don't
the
think
way
we
we've been talking
understand
about.
that at all at this, but I mean, I think we're working towards it. But a lot of the effort now is towards trying to understand exactly, what are the consequences of this dialogue, basically, between our existing self and, the new stuff that we're constantly being exposed to that forces a dialogue of the sort you're describing. How does that work? I mean, how does the system constantly updating itself, so that it stays true to the current reality rather than just basically reflecting what used to be, what might still be, but might not be anymore. So
Yeah,
this
because everything's always changing.
is everything in the world is changing, right? Now,
Yeah,
some of it's changing at a scale that it doesn't matter. We don't have to, it doesn't matter to us
you have to think about it. Yeah,
that we can't step into the same water in the river. It's still the river, right? It's not the same
yeah,
water exactly. The molecules are different, right? So that's that old example that scale doesn't matter, but there are scales that it really does matter. That there are changes that really now the river no longer flows in this direction, but because of a flood, it now flows in that direction. Okay, that's something we better be aware of, so to speak, and
yeah.
and
Do you
and all
feel,
of
Lynn,
that.
we're trying to become aware of that in a different way now than we've
I
ever
think the
had
field is
as
very
humans?
much focused on this question of the dynamics of memory, how memories are, constantly changing as a function of current experiences. That's what I'm
And
focused
how that affects the future, because I think
on.
that's the
Well,
thing too, when we were talking about trying to hold both things at once, that
yeah, yeah,
we're also having to realize that what we're remembering is also what we're imagining or putting forward in a way. They're not the same thing, but in the way we're talking about, they're very connected. And also, that's the difference between the sunflowers in my backyard that don't move and the reason that we need to have these mappings and be aware of them, because,
right. Now
it's a different
they
kind
may
of movement.
predict those sunflowers may actually have enough of a memory, so to speak, that they like a 24-hour clock, let's say. So that they will predict when they ought to shift, according to where the sun is in the sky. I don't know if that's true or not, but I wouldn't be surprised if they were capable of that because that's just a timing
They're
mechanism.
definitely moving in relation to everything that we do and
Well,
that happens. So
what
so much
happens if you
more immediate than
take
yeah.
them out of the sun and put them in a place where there's constant illumination and see if they still move, on some regular basis according to the clock that they would have moved, if they were out there in the real world. I mean, how built in is this circadian kind of rhythm, basically? I mean, a lot
Yeah,
of it again it has been so built in over evolutionary time because fundamentally the cycles of light and dark haven't changed, right? Uh,
right.
in a given biome, depending on where
Yeah.
these plants are
The
living.
regularities that shift are much smaller than what we're dealing with once we get to what we're talking about now. So, I mean, of course, we have the sunflower-ness in us too, right? We have these kind of, rhythms, but
We do, yeah, yeah, yeah.
we've also developed this way of communicating with ourselves and communicating with each other and all that happening at once and
Yeah.
needing these ways to, scaffold all of that stuff. And
Hmm. Hmm. Hmm.
that feels to me really important, especially when we think about this kind of a paper and action at a distance.
Yeah.
Um, how we're all, how we're all doing this for each other in strange ways right now,
Hmm.
that we
Hmm.
are
Hmm.
trying to see more clearly. Do you,
Hmm.
you know,
Good
and
luck
it's
with that.
It's so messy. Yeah.
Yeah, good luck with that part. Yeah, no, I agree. But certainly the dynamics of memory and the way in which we update our knowledge, and the systems that allow us to do that and so on, that's kind of a focus that I'm focusing on that right now. And I'm not the only one. There's quite a few people who are. I mean, we're just about to publish a paper in TINS, just got accepted a couple of days ago, on the role of the locus coeruleus in orchestrating, you know, this updating ability and sort of influencing it, whether you update a memory or whether you decide, nah, this really isn't related to my prior experience. This is a new experience, and I'm going to create a separate memory for this thing. Well, that's a fundamental decision the brain is making, all the time. How does it do that? How do so and when it decides to update, what are the mechanisms that determine how it updates a memory so that it sort of deletes the things that are no longer relevant and adds new things that are now relevant, versus when it's creating a brand new memory, how does it keep it separate from this older memory that, you initially activated because you thought that was what the situation was going to be. I mean, those are all choices the brain has to make, as it continues to try to build internal models that will work in the future. It's all pointed towards creating models that will be adaptive in the future.
Yeah. And it's not just the brain, it's the body and us in
And it's all
communication
of it.
about it now too.
Yeah, it's all of it.
So yeah. Well, has it helped you? I mean, do you have any? I don't think I've asked you about love yet, and this is love and philosophy. So I have to finally, Lynn, ask you about that word. And do you see any relation at all to the work you
I
do
don't have
in
any,
that?
I have no insights into it. I struggle. I have
But
no,
but all this work that you've done, we talked about 50 years ago, you guys were writing this book, and
yeah.
is there something about what you do that connects to care and to like thinking that it's,
I
or do
don't
you just, you just do it?
I wouldn't say in any direct way. I mean, beyond the fact that, having a reasonably good model of the world, I would say allows you to behave more appropriately, contextually appropriately, when, restaurant voice versus home voice, all these things that you do that are contextually appropriate, that are socially important, that's that kind of depends upon this system in a way, but it's not really, I don't think understanding this system will give us much of a handle on, you know, on compassion or resilience or any of those things. I think they're really in another zone, basically. This is a more kind of purely cognitive, purely knowledge-based system, that can be deployed to, in useful ways in all of those social domains. And there really are parts of the hippocampus, CA2 in particular, that are very important for social interactions. We know that social stuff gets caught up in the system, but I don't know that this hippocampal formation system makes fundamental contributions to those things. It makes these kind of contextual contributions and so on, shadings, but I don't think it helps me understand emotion at all, quite honestly. I wish that that were not true, but I don't think it helps me understand the basis of emotion, the basis of any of these sort of more socially oriented cognitions. I mean, I don't consider emotion separate from cognition, but the emotional side of our cognitive life, I think is really not so much in the zone of the hippocampus. But because of what it does, it influences a lot of that. I mean, I keep reading papers where people claim the role of the ventral or anterior hippocampus is anxiety. And basically all of the behavioral tests that they tend to use are ones that measure anxiety from being in open spaces or being in places that
Mm,
are
right.
fearful. So it's not so much about anxiety, but it's about the kind of anxiety that comes from being in a space that you're uncomfortable in. So somehow, you know, the notion of space gets caught up in with anxiety, but it isn't, but there are plenty of anxieties that have nothing to do with space. You're anxious when you see a spider and you don't know why. I mean, that doesn't matter where you are, right? So I don't think it's fundamental to those things, but I think it can intertwine with those things under some circumstances. There's a Venn diagram overlap between, the role of facial models of the world and these other things, that remain to.
I lost you. I lost you, Lynn. I can't hear you or see you. Are you still there?
Yeah, I think my system kicked out basically, and I
Yeah,
don't know just at that moment. But anyway, the hour is up. So I
yeah,
actually thought initially that your system kicked out, but then I saw that I was suddenly offline briefly. I don't know why.
yeah. I don't know, but I think we got most of it. But oh, you're frozen again.
I think we're we're back in connection, but I now have to.
Yeah, and me too. I just wanted
All
to say,
right.
if we did think of the hippocampus as like a way that we're somehow connected to communication in the way we were talking about, then it would also make a lot of sense to those points you were making about possibly extending the circle of care. Yeah.
Yeah. All right. Well, sure, but it's a stretch, but it's a stretch that I'm happy to see you make. But
Yeah, well,
I
I'm making it, so
good. Go for
based
it.
on your research or building
Yeah.
upon. So, all right.
Good.
Well, thanks for
I
today.
look
I
forward
really
to hearing
appreciate
it.
it.
Okay, we can connect up again in sometime in a few more months, when I'm back in Tucson temporarily. So I'll be back in about 10 days and settling in. I'll be pretty busy through October and November. Then the whole family is kind of what, it's going to be in and out,
Yeah,
and we're a lot of things
holiday.
going on back in Tucson, not to, and in America, that et cetera.
Yeah.
So I don't know what that's all going to be like, but we can stay in touch, and we'll try to set up another time sometime down the road.
Awesome. Well, I look forward to it. I want to read the paper
Yeah.
that's coming out too. That might be a good one to talk
Yeah,
about.
prod me to send you a copy of this paper on
Okay, and
local.
that video. I want you to send me the video of this paper
Oh, yeah. Send me an
or the
email
talk. I'll email you
reminding me
with
of
some
things
other
I
stuff too.
promised you.
Okay.
Okay. All
Thanks
right.
a
Take
lot,
care.
Lynn. Be well.
All right. You
Appreciate it.
too. Bye
Bye.
bye.